Please welcome Konstantin Polychronopoulos and our panel.
Does the mic work? Thank you. Good afternoon, everybody, and thank you for your perseverance in late afternoon, but we kept the best for last. So I'm happy to welcome here Fazil Osman, distinguished engineer at Broadcom. Is Fazil. Christopher Moezzi, vice president of marketing at Cavium. Christopher. Dror Goldenberg, vice president of software architecture at Mellanox.
Hello.
And Sujal Das, chief marketing and scientific officer at Netronome.
Thank you.
And the topic of the panel is, what else? Smartnics, the future. So we're going to have Fazil come up first to the podium. Every speaker will present for about 5 minutes, and then we'll take questions about anything related to Smartnics and more. So please, Fazil.
Okay. Can you hear me? Okay, so I'm Fazil, I'm from Broadcom, and what I want to talk to you about is what Broadcom sees as with Smartnics and why we're doing Smartnics. So we're the newcomer to the game. Netronome and Cavium have been doing this for years. They've pioneered it. They've made a lot of progress on it. So now we're entering the market. So what I want to talk about is, real quickly, is why we're doing Smartnics, and then what our model is from a software development perspective. So why are we doing why did we get into the Smartnic business? We see the benefits. I think the benefits are getting pretty clear now when you talk to customers, you talk to both operators of data centers and to developers of applications. We're seeing some of the benefits. So the biggest one that everyone talks about is if you offload the right thing into the Smartnic, you get a better TCO in your data center. I mean, the standard thing people talk about, you take your vSwitch, you move it into the Smartnic, you free up CPU cycles. But also, not only do you free up CPU cycles, but you make it a lot easier for your application to be managed because you don't get data moving in and out of memory, you get less interrupts and all kinds of stuff in the CPU that makes life a lot easier. So doing offloads is good for TCO. But the other thing that happens that we hear a lot of now is that you get better security. Part of the model being that when you move back again to the vSwitch model, you move the vSwitch into the Smartnic, it's hard for an application above it or a rogue user to come in and get into your network. So that seems to be actually resonating quite a bit with developers out there. And also, one of the things that we hear from especially our large customers is about the ability to do faster deployment. It decouples what they're doing from those applications, whether it be a networking application, a storage application, from the application that's running on the host OS itself. Because they can go in there from the network, come in, deploy and do an update and do it at a different rate than having to wait till that's integrated into the kernel that's running on the host, and what's it released on that kernel, can it support this, can it not? It speeds up a lot of the deployment issues. So that's the main benefits we see out there. However, what we find is that people are having a hard time with picking a Smartnic. I mean, there's so many different models of Smartnics. This is kind of sort of gives you the feel that if you look at across the board of what we all have here, functionality changes by Smartnics, the cost and power changes. So which ones do you use? How do you make the decisions? And that's really, I think, is the challenge that we as vendors have to solve, working with both the guys, the server vendors, and with developers out there to make this happen. So our goal is we want to see Smartnics as a standard SKU in a server. That's the ultimate goal. When you buy your server, you go to Dell, HP, Lenovo, whoever it is, you should be able to go in there and say, I want a 10 gig NIC, a 25 gig NIC, I want Rocky, I want iWarp, I want a Smartnic with this feature set, and here's what I want, and that's how SmartNIC should come out. So what does that mean? It means it has to come from more than one of us. It can't be, this is not, you can't just standardize on here's what Broadcom is doing or here's what Mellanox is doing. You got to look at what we're all doing and try and come up with models that work for across multiple platforms, multiple vendors. And you got to put them in standard form factors that fit in servers, PCIe or CPMES, whatever the latest is going to be in the next few years, that's all we got to go for. And the way I think when we talk to the server vendors, what would make it easy for them to put this in their systems is that it just looks like a networking device, or it looks like a storage device, a block device. And then all the other stuff that's done from a smarts that's inside the SmartNIC, the application doesn't see, the OS doesn't see, it just sees an Ethernet device, it's an Ethernet device, or it sees a block device. I think that making that model there is, I think, going to make life a lot easier for us to integrate into the servers. Otherwise, it gets really complicated. They worry about how much they have to test and what do they have to know about what's going on in the SmartNIC. The SmartNIC should not be something that the server vendor has to worry about what's internal to the SmartNIC. They have to worry just about how do you connect it into their server, and then the rest is done by an ecosystem of developers that's going to make the rest of it happen. And the other thing that we think is really important, especially when we talk to software developers, but I think the key for us is to go after software developers who are writing those applications. Again, it's back to vSwitches. We see a lot of stuff also on the storage side where people doing storage applications. Is you have to be able to move the application from the host to the SmartNIC very easily. And the reason for that is because people start with their development on a server, and then they want to move it to a SmartNIC. And you want to make these, when they deploy it, to be deployed at the same time. You don't want to say, well, you need 6 months or 9 months before you can deploy it. Okay, so our model then for how you look at a SmartNIC from a sort of a programmer's perspective, from the host side, you see it as a standard device, networking or block. And then what you have inside there is a standard server class Linux environment. Really, the model we use that term at one time called a server NIC. There's an embedded server inside there. Now we have all these accelerators. We all create accelerators that differentiate us from each other in terms of capabilities and performance and everything else. But the core is you want it to be a way it's easy for you to port that software that was running on the host into the SmartNIC. And then there's, of course, the network interface. So that's our sort of 5-minute pitch on our view of the world.
Thank you, Fazil.
Yes?
Christopher?
Thank you. Thank you.
The big
guy.
yeah.
Great.
Got it. Thank you.
That'll be my turn, I guess.
I guess it's your turn.
Dror, sorry.
Okay. So, hi everyone. I'm Dror Goldenberg. I'm going to talk about SmartNIC at Mellanox and the way we see things. And I want to give some NFV perspective here, because we see NFV is one of the key drivers for performance. So NFV is about packet processing. It's packet processing because we implement network functions, and it has to be fast. So looking a little bit ahead into the future, looking at 200 gigabit per second, 1,500 byte packets, they can generate about 16 million packets per second. And if you're talking about 64 byte packets, we're talking about almost 300 million packets per second. And when you want to process them in software, because NFV is about running stuff on standard commodity CPUs, then we start talking about L3 cache access, how many spin locks I can take and relinquish, and so on. And that's pretty sane numbers, right? You can almost do a full memory access per packet if it's 1,500 byte packets. And if it's a 64 byte packet, you basically have budget for nothing. And all those things really mean that in order to succeed in NFV and do some really efficient computation, you really have to look at packet processing with acceleration. And acceleration is becoming must-tier for NFV. And we saw similar things coming in other markets, like using GPU for graphics, using GPU for scientific computation. And we're also seeing now new chips that are targeting at AI. So acceleration is not something new. And we need to make sure that this acceleration is becoming very transparent to the application, starting all from software first, and then accelerating that in hardware. If we look at NFV, and I want to focus here on the data path, of course, then usually you see an infrastructure in place that is running the underlying SDN, switching packets in the hypervisor or the host, and then those packets are sent to the VNFs that can be in VMs or in containers. And this is all about packet processing. It both send receive in 2 layers at least, and packet processing. And what do we do there? So I threw up a couple of items that people are doing, and they can definitely be a longer list, of course. We're doing encapsulation, decapsulation, match action tables, virtual switch, firewalls, IPsec, you just name those things. And since you don't have budget in the CPU, with a dedicated pipeline that you can have in the NIC, you can really accelerate those functions. And just giving some numbers that we have on vSwitch acceleration, we saw ability to get 10x better packet per second rate at 0% CPU utilization by removing the need to do the switching in the software. Similarly, on IPsec, we managed to do 4x better bandwidth at much lower CPU utilization. So all of those things really show the value of acceleration in the hardware. Again, need to make this acceleration transparent to the software and accelerating the existing software, but those things really bring value and can make those NFV deployment much more cost effective. So I really want to say something about SmartNIC. And it's easier to say what's a vanilla NIC. Vanilla NIC is basically a NIC that has like checksum offload and large-end offload. And everybody knows that. And a vanilla NIC, usually when you start deploying software-defined networks, it just breaks. You have no offload. You just can send and receive packets. You get all the functionality, but the performance is 0. And then what I see is SmartNIC is a whole slew of product lines that are available. And you can pick whatever makes sense for your deployment. I want to start with the ASIC. The ASIC will have all those offload. It will be able to do some advanced data plane offloads. It will differentiate between different vendors, but obviously you can do encapsulation, decapsulation, SRIOV. Maybe you can do some security functions, firewalls, IPsec, crypto, and so on. And some of the devices do have programmability. Maybe it's not so easy to program them. Maybe we should standardize on something like P4 or eBPF to program them. But there is some programmability in those devices, and you can deploy new headers, even if you're already up in the field with equipment. And those devices will be the most efficient in terms of power and cost because they will be gate-based and gate-based state machine pipeline, and they will be the most cheapest devices and with the lowest power. And then people are looking at FPGA to enable additional programmability. I didn't mark it as 100% programmability because it's not easy to program FPGA. Don't try it at home. So for every software programmer, it's quite hard to program an FPGA. And again, the efficiency is very good. However, you do bear a cost of additional FPGA and additional power. Last thing is a SmartNIC that is ARM-based. The reason I mention ARM-based because we want something standard, something that can run your operating system of choice. You can run your cell phone application there, or you can run most likely things like DPDK, Linux, and OVS, and all those kind of nice things that we all talked about that can run in the server. They can be run in the NIC. It has a full level of programmability. You can do whatever you want there because it's Linux. But in terms of efficiency, it will be much lower efficiency because you have the baggage of additional ARM cores. And sometimes if the more functionality you move to the ARM cores, you may hit some performance challenges. But the last thing that differentiates that SmartNIC is the ability to also run the control plane. So you can run things like the SDN stack inside the NIC, or as you mentioned, you may even want to run a storage stack inside it, and that creates some decoupling. It can be a more secure enclave for your application to run, for the network virtualization application to run into the NIC, and also it can enable bare metal provisioning. Okay. that's pretty much it.
Thank you very much. And now it is Christopher's turn.
Very good. Thank you. My name is Chris Moezzi. I'm with Cavium. 30 seconds on Cavium and who we are. So Cavium's a semiconductor company that offers software and solutions and adapters. We were founded in 2001. We went public in 2007. We've enjoyed a pretty high compounded annual growth rate since our IPO, almost close to 30%. And we target multiple verticals with our products. So topic of my talk is a smart NIC a smart choice? So to help up-level this conversation, let's talk about the target markets that smart NICs can be positioned in. At Cavium, we sort of categorize these in 10 different markets, ranging from hyperscale, data center, to enterprise, public-private hybrid cloud, telco NFV, storage and hyper-converged environments, content data delivery, security, financial services, machine learning, and high-performance computing. In fact, we've been pretty successful in engaging with a number of hyperscalers over the past several years, and today we're engaged with four out of the Super 7 cloud titans and mega data centers. Through those engagements, we've learned a lot, in addition to engaging with a number of security appliance vendors. We've applied those learnings to other segments, including enterprise, NFV, and storage. And we've understood that each of these verticals have their own dynamics. And when you look at different kinds of smart NICs, you can sort of categorize them in three different buckets. Smart NICs that are multi-core based, those could be MIPS or ARM-based or even RISC-based, FPGA-based smart NICs, or even GPUs that are smart NICs. Each of these types of NICs have their own benefits and merits and demerits and are useful depending on which of these markets you're targeting. Each of these markets themselves have particular characteristics. Like NFV, telco NFV has the characteristic of high performance, small packet count, 64-byte packet requirement. Hyperscale data center has the dynamics of having a lot of DevOps teams. There's a lot of proprietary development that can be done there versus telco NFV, that there's a huge reliance on open source software and cloud management components like OpenStack versus mega data centers that would develop their own code because they believe in developing their own cloud management software stacks to get the scale. So to date, we have been able to ship north of 1 million smart NICs since 2012 when we first got associated with one of the biggest hyperscale data centers. And since then, we continue to ship into different markets. So when we look at some of the value propositions of smart NICs, as was mentioned by a couple of my colleagues before from Mellanox and Broadcom, the biggest value is offload. So imagine you have a smart NIC that supports 10 gig functionality, and you want to offload OVS, which is a pretty popular offload. This value proposition was very early understood by the hyperscalers because they realized in order to be able to get efficiencies out of their servers, they need to go to virtualization. In order to take advantage of virtualization, they need to be able to switch between the VMs. They could have used external Tor switches, but an alternative to that is to bring that switch in soft switch form, OVS or variations of OVS, proprietary variations, and run that inside the smart NIC in order to offload those CPUs. So imagine OVS run in a kernel takes about 6 to 8 cores versus the 14 cores that you'd have available in a single socket Intel processor. When you use a smart NIC, depending on whether you do control plane and data plane, in our case we do both, we could save all those cores. Now, when data rates go from 10 to 25 or from 40 to 100, the problem gets exacerbated. And on top of that, when you have additional functions like encryption, decryption, and security that you're bringing into the server from the perimeter, then you end up losing almost double the number of cores that I'm showing over here. So imagine losing 12 to 14 cores out of a dual socket 14-core Intel processor. You've lost half of your compute, which is just not acceptable. So the idea is to use smart NICs so that you could improve your VM density, reduce your cost, and increase your utilization factor for your servers. In fact, we've done some analysis on this to sort of see that if you were to deploy a SmartNIC in conjunction with an L2 basic vanilla NIC and essentially have the same number of VMs, assume about, let's say, a single rack of 4 VMs per core, 14 cores, you're going to basically have 2,000 VMs per core, 2,000 VMs per rack, and you'd see in this graph, we show that you can get about 40% better CapEx efficiency and 35% better OpEx efficiency when you use a SmartNIC. So looking under the hood, what does a SmartNIC look like, and what's the anatomy? So basically, you have an SoC that runs on an adapter, and you've got multiple layers. Those layers can be a combination of L2 NICs plus RDMA functionality that gives you low latency transport. Built on top of that, you've got network and server virtualization functions that do your things like VXLAN and GenEve offloads. This could be a multi-core CPU with a number of different kinds of APIs like ODP, DPDK, eBBF, and P4 XDP. And on top of that, you have data planes like OVS, new data planes like VPP, and if you're targeting storage for disaggregated storage, you're looking at NVMe over Fabric acceleration. And on top of all that, you have a huge ecosystem of open source software, hypervisors, and operating systems. So think of it as a platform for accelerating innovation. And one of the challenges I see here is, as a community of SmartNIC vendors, we should be able to simplify this and pre-integrate a number of these functions into SmartNICs to simplify life for app developers so that they can develop their apps and be sure that the data path that those apps rely on would be accelerated to its max efficiency. So what can we expect coming next? I think that the value of SmartNICs will be appreciated more and more with the transitions to higher speeds. I think that they can be used to scaling out architectures and bring security from the perimeter of the network into the server, especially with the advent of things like IoT and autonomous driving. And lastly, I think that things like certifications that can help accelerate the adoption of SmartNICs by software suppliers can help build trust in the end user community as things like container apps, telemetry, and standardization around virtual machine and VM migration get solved. Thank you.
Thank you, Christopher. And Sujal?
Right, thank you. All right, so moving on to the last section here before we open up for questions. So I'm going to talk about success factors. I think a lot of these points were touched upon, but I'll get into more details on some of the specifics around the deployment success factors. So I broke it down into 6 legs, and I'm going to talk about each of these one by one. I think the first one that you see on the left is the entire ecosystem of hardware and software players that's helping the SmartNIC ecosystem thrive. There are multiple healthy initiatives going on in all the 3 areas that I'm showing here. Firstly, hardware suppliers, and all of us are sitting here. Welcome to Broadcom into the community, and it's a good, healthy ecosystem of hardware suppliers available today. On the software ecosystem side, there are multiple initiatives going on in Linux.org, for example, in the area of OVSTC for enabling offloads into SmartNICs. Similarly, with the IOVisor eBPF, JIT compilers are being built to offload eBPF bytecode into SmartNICs, for example, as well as other software such as OpenContrail that support offloading into SmartNICs. So the software ecosystem is growing, and also there are many commercial solutions available today that actually offload into SmartNICs, and these use open source projects, for example. So the ecosystem is robust and it's growing rapidly. Of course, being driven by some very mainstream use cases that you heard other gentlemen talked about. I believe, network virtualization obviously is a killer app for SmartNICs, especially when you go to data rates beyond 10 gig, 25 gig, 50, 100. And my colleagues have, my panelists, partners have spoken about that a lot. But two things I want to highlight even further is the ability to do distributed security and telemetry, being able to do those close to the VMs in the servers, being able to do those close to the containers are other killer applications that ride on top of network virtualization or even in bare metal servers. So these are core emerging use cases, as well as microservices, as we heard a lot today around eBPF, layer 7 proxies, being able to fire up new data planes for containers as needed and take them off, for example, and being able to actually apply those to the efficiencies of SmartNICs. The third leg that you see, which is balanced silicon architecture, this is very critical for all of us to understand. We have been doing SmartNICs at Netronome for a while now, and SmartNICs are different from traditional NICs. Besides the SerDes and the MAC that you have, and the PCIe that lets you get the packets in and out of the host, there are some new things in a SmartNIC, such as the processing cores, where you actually run the data plane, whether it's the OVS data plane or eBPF bytecode that you offload to, as well as access to memory that could be on the SmartNIC, and access to hardware accelerators. So all of these have to work in tandem, and the weakest link in this could kill the performance. And this kind of showed up a little bit in Dror slides, for example. But the point here is that having 50 gig, 25 gig SerDes and MAC is not sufficient. The data plane has to be able to run at the right packets per second performance through the entire system, which includes the packet processing cores and the memory. Fourth leg of the success factors is availability of open data plane software. There are many different Linux-based data plane available today, starting with Open vSwitch, Linux TC, IP tables, etc. Some of these are kernel-based, some are user space-based, and the important thing for SmartNICs here is that the interfaces for offloading have to be upstreamed, they have to be standard, and they have to be same across multiple vendors. That's what will make ease of use for end users possible. So there are multiple different kernel versus user space options here. As far as Netronome is concerned, our mantra is that you never bet against the kernel. So we focus on the kernel. That's why I highlighted those. And our focus is, for example, in terms of offloading, is OVS using the TC packet filtering mechanism in the kernel, or using eBPF XTP. Fifth point I'm making here is balanced software architecture. So there's control plane, and then within the data plane there is sometimes something called slow path and fast path, right? For example, in the OVS architecture, you'll see a slow path and a fast path. Where you run these makes a big difference, because when packets come in and go through a SmartNIC and go to the host or go out through the other port, there's a lot of interaction that goes on between the fast path, slow path, as well as control plane. And how they are placed between the x86 server on the host and the processing cores on the SmartNIC, and the SmartNIC could have different kinds of processing cores. And how you place those is also critical. Finally, there's a notion of single-threaded performance versus multi-threaded performance. So some applications, such as the fast path in a data plane, could benefit tremendously from a multi-threaded processing environment. Very similar to what you see in the world of AI with GPUs, where doing some of these functions in the GPU just makes sense compared to doing it in a single-threaded general-purpose processing environment. So these are key balanced architecture, software architecture points that are important in delivering the right level of price performance that one would expect from a SmartNIC. Finally, programming. That's, of course, is very important. And there are many different ways of programming, as other folks have just pointed out. You could program with C, you could program with P4. P4 is very easy. It's abstracted to the point where for a network designer, programming in P4 is just natural. And then there is evolving programming methods such as LLVM, using the LLVM and using the eBPF JIT compiler to actually write code once that goes into the kernel. You heard a lot of that today, but using the same concept of a JIT compiler that is available on the Linux kernel to enable user space code created using the LLVM to go into the kernel, you can also transparently get those code into a Smartening. So what this means is, basically, I call it the holy grail of programming, is that you're programming data plane code that goes into the kernel dynamically, and it can also be accelerated if there is a Smartening sitting on the server. And you just write code once and you don't know where it's running. It just automatically runs in the right place. So all in all, vendor-agnostic programming is very easy. At Netronome, we are focusing heavily on enabling C and P4 on top of a JIT compiler LLVM framework to enable ease of programming with Smartenings. Thank you.
Thank you very much, Sujal. And with that, let me take the first question, and we're going to open it to all of you for questions you may have on this very important topic. I like to be a little bit controversial. It's late afternoon, so let's throw a question there that is somewhat controversial. Not controversial. It's philosophical, I should say. By the way, I'm a very strong believer in SmartNICs and the future of SmartNICs, especially with respect to NFV and 5G requirements. But if we look at this, it looks like as if we are chasing our tail. And what I mean by that is we try to pull functionality off the host processor, off the host CPU, put it on the NIC, simply because we want to avoid the memory copies, we want to bypass the bottleneck of the PCI bus, the system bus, etc., right? So bring the processing very close to the network interface. Makes a lot of sense, right? So why not bring the host processor on the NIC as well? Because we do packet processing, then we go to layer 7 to do processing there. Why start pushing content up to the memory instead of bringing the processor on the NIC? And that's what I mean by chasing our tail. Then we have a NIC server. So does that make any sense?
I think that's what we're building, right?
That is what we're building.
I think that's what we're building.
So
we're running ARM 64-bit ARM, running extended Linux.
Exactly. So why do we need then the motherboard?
The motherboard is there because the applications that typically run on your server, not, let's say you're one of the big guys and you're doing search. I mean, a multi-core, highly multi-threaded x86 is the right platform for doing that. An embedded ARM that we put, even though it's a server class ARM, is not the right platform for doing that. You won't get the same performance. If you try and optimize for that same performance there, then your power and your costs go up. So I think we optimize what we do, and I think we all do. I'm not talking about just Broadcom. We optimize for what's good for doing network-based kind of applications, not to run an application like search or machine learning or anything that you're running on a server where you want highly multi-threaded capabilities.
Okay. Anybody else?
So one of the biggest benefits of a Smartening is, I think what both Chris and Dror showed, is how many CPU cores you are consuming doing networking on the server, right? I think there was some data shown, and we have seen as many as 16 to even 20 cores taken up on the server doing networking, such as what we talked about today. And it's important to note that the moment you have more entries in the tables, whether they are flow entries, the performance goes down significantly. Therefore, it's not just a matter of getting something that's on the host across the PCI down to a Smartening. There's more optimizations that need to be done in the Smartening.
Yeah, my question though is why don't you bring also the host CPU onto the NIC?
There are things that the host CPU is good at
Yeah.
and was optimized for so many years for doing this, and so many applications have been tuned for doing this. So there are things that make sense to offload in a NIC and things that don't make sense. Let's take one example, IPsec, okay? It so much makes sense to decrypt and encrypt the data on the fly. Why would a server mess with it? So you don't even do it in the ARM. You can even do it in hardware, state machine, and pipeline, and all of that. That really makes sense. And if you see that every application that deploys a SmartNIC needs IPsec, so just put it in gates in that machine.
Exactly. So there's this concept of serverless, which basically means that I don't want to have to pay for things that I can't monetize. So I think one of the best use cases for SmartNICs is to essentially offload functionality that then relieves enough cores so that bare metal suppliers, hosting companies can actually then host applications by other companies and be able to then monetize that.
Absolutely. Perhaps I didn't phrase my question right, but let's open it, because if you have essentially unlimited throughput system bus and very low latency memory, you just put more host CPUs there, and you do everything right there. Right? So, but let's take the first question from the audience.
I sort of had a similar question. Modern systems, at least some modern systems, are moving towards interconnects that are cache coherent. So you create what you're talking about, Konstantin, which is really symmetric access to core memory from CPU or an offload accelerator. First, how critical do you see that in the SmartNIC space? And then
there is absolutely no reason that when we have cache coherent interconnects, that SmartNICs won't be connected to a cache coherent interconnect.
I understand that. I'm wondering how critical you think it is to the value of SmartNICs?
I think there's lots of applications that don't need it. I think there will be applications that will need it, but I think today, I mean, we talk about things like OVS. I mean, the OVS offload is a typical one. You don't need cache coherency for that, because that's something which you can run totally autonomously or self-contained inside the SmartNIC. But later on, you might want to do applications where you are processing stuff on the way out and sharing data with the application. But we can't do that today, so I think we can't go after those applications. When those cache coherent interconnects, like whether it's C6 or whatever it is that comes out, are there, we'll move in that direction. But there's enough, I think, today. We see enough today value without needing that.
It can help. I believe that as you have larger networks, large number of users, more containers, more policy rules, larger tables, the need for cache coherency with the host memory would increase. I believe at the speeds and feeds that we're at today on the servers, pretty much 10 gig going to 25 and maybe some 50. It's becoming more important, but as we go forward, as the scale increases in terms of table sizes and bandwidth requirements, this will become much more of a critical need going forward.
For classical I/O, sending, receiving packets, or even doing storage, the basic stuff like writing and reading a block, PCI and whatever I/O traditional model works perfectly fine. I think cache coherency will become for more intimate application acceleration that will go even beyond I/O, or where things start to blur a little bit. If you look at things like storage class memory and other things where the I/O doesn't look anymore like a classical.
Right, but that's where SmartNICs are going.
Yes, and the I/O buses are evolving in that way. You mentioned, Fazil mentioned C6, and PCI will evolve over time, and they will enable those new paradigms.
I think we just need your favorite server vendor, server CPU vendor to support it.
Exactly. Yeah. So you're going to.
I mean, that's really the issue for us, right? I mean, we can putting it in there and supporting it and be able to do it. The question is, what's the whole ecosystem that would?
Right. So more than that, you're going to see more I/O coherency. So you have
I/O coherency is definitely,
and from IBM or C6 and Gen Z. These are all examples that we will find on SmartNICs going forward. to enable that kind of coherency.
Yeah, I believe, just to follow up, to capitalize on that question, that's a good question. I think that, if you look at the evolution of virtualization cloud computing, right, we tend to put more and more functionality on the virtual machine and the hypervisor, right? So we are moving towards a space where the virtual machine itself has virtual switching, firewall, customized firewall, and a bunch of other networking functionality that now you're asking to rip away and put it on the NIC, right? That is going to create a source of inefficiency that needs to be addressed, right? How much the NIC, the smart NIC, is going to give us a boost and how much it's going to slow us down because of this ripping apart, let alone the complexities in software engineering, etc. So that's a good question, but I think we see more and more.
Can I ask a related? The reason I was asking that question was for a different reason, which is I'm trying to understand. I totally get the offload switching down to hardware, but I think it becomes really interesting when you have higher class services like network functions that are pretty complex, and that's why I was wondering. I think the programming model is critical, and I'm trying to understand where you see the balance of sharing memory and kind of this that blurred line of application versus hardware acceleration.
Yeah. Thank you for the question.
So thanks for the presentation. We've been playing with SmartNICs and we see the value and all your use cases are very relevant. The challenge we have is there's 4 vendors on the table, and each one's got multiple SmartNICs, and everyone's programmable slightly different. So to support that becomes incredibly complex.
That's correct.
You all talked about the need for standardization, but you seem to be talking about it in silos. When are we going to see some standardization to help us poor consumers of these things have an easier life? Thanks.
Thank you. Who wants to take the question?
I can start. So it's a very valid point you're making. So I think there's always a trade-off between just going completely general purpose and C programming that you're used to in x86 and taking it all the way to SmartNIC, and then you lose the efficiencies, right? At Netronome, our belief is that if you abstract it out to a higher level, P4 is a good example. If you extract it up on top of an LLVM, eBPF, JIT environment, you're letting the task of actually placing the code in the SmartNICs to the vendors, and you focus on programming at a higher level, and that can help bring uniformity in how a SmartNICs can be programmed in the future.
My answer in 2 words is maybe Linux and open source. I think that will be the standard. The way we look at acceleration is accelerating the application. So without any mean to torture our customer, we just want you to write the very same software, and if there is offload down there in the card, it will immediately get offload because it's running the Linux, and we'll take care of all the underlying plumbing of make sure that it happens.
Thank you.
Exactly.
And we'll take one more question. We're running out of time, so a quick question, quick response.
So actually, my question is a follow-up from the previous question. So more than standardization is how you can make, now that you have all this programmability and you have all this like programmability from the network into the SmartNICs into the data planes, how you make that programmability accessible to the user? How you can make it easy to the user? So you guys talk about P4. So what's your stand-up on P4? And what are you looking into your roadmaps? How do you see P4 being supported going forward?
Our model for P4 is we run a Linux environment inside our chip, and we can run XDP, eBPF inside there, and P4 can be pushed down into XDP. So we see actually that extension of P4 is for the network. SmartNIC sits on the edge of the network and the server. And I think what SmartNICs do, especially when you have the ability to run a Linux kernel inside the SmartNIC, you can cross it, you can be on that boundary. We can use XDP to do P4, we can do other things even within XDP or not XDP. So I think it's a great Linux running on there is our answer.
Great. Let's thank our panelists, and thank you very much.
Thank you.